Okay, so this is question 5 on the foundation paper. An electric car has a motor that is powered by a battery, and what we can see is the battery um, produces a maximum acceleration of 4.8, 420 mass of the power source, and a distance of 220, and a maximum power output of 200 kilowatts. And then a diesel has a lower maximum acceleration. The power source, the fuel is lower in mass, it moves further distance, and its maximum output is in terms of power is less. Okay, so give two advantages of the diesel car compared to the electric car in the table. So we're looking at the advantage of diesel. So you can clearly see that the diesel car has a longer range. It can travel further. Okay, so 1,120 kilometers it can travel on. Okay, and the other advantage, if you look at it, is the fuel is lower in mass. Okay, so the lower mass of the power source in kilograms, and that's your second advantage based on the information that's given to us in the table. That's what we are using. The second part B, he asks for the mass of the battery in the electric car is 420, and the total mass of the electric car is 1,610. So calculate the mass of the battery as a percentage of the total mass of the car. So it's 420 divided by 160, 1610 times by 100, and that's 26% of the total mass. So the battery for an electric car, out of the entire weight of the car, is 26%. Designers of electric car batteries want to increase the amount of energy that can be stored in the battery. Suggest two reasons why. Okay, so if we have more energy, then what we could do is we can have the car moving further for the same battery. So that's one advantage that it could have. So an increase in range, and also if it has more energy, it could also have more power, a larger output power, and that is something else that we can see. Okay, so we can have a larger maximum acceleration or larger output power compared to before. Okay, so want to increase the amount of energy and increase the range. Also, you can think of less fuel, less in terms of less distance. No, sorry, less cost due to a further range, because it can travel further, so it's more cost effective. That's the word I was looking for. And part D, the charger has a power of 7,000 watts, and it takes some time to get to 42,000 joules of energy to be delivered to the car battery. So how long will this take? So we need to look for a formula that links power and energy and time, because we want to work out time, and that is power equals energy divided by time. And when we rearrange that formula, that's time is energy over power, and that's 42,000 divided by 7,000, and it will take 600 seconds to deliver that amount of power.